Here's a situation. You have a 2 kilogram cart with a 0.1 Newton friction force on it, attached to a string which runs over a pulley, which is attached to a 50-gram mass hanging on the end. Your job in black is to find the acceleration of the system, and then the second part, find the tension in the string that attaches the two. Now we must assume that there is no friction on the pulley and that the pulley has a minimal mass. So the first part's in blue, starts out with a 50-gram mass. 50-gram mass, of course, that would be 0.050 kilograms because there are 1,000 grams in 1 kilogram. Therefore, the weight, using G is 10 meters per second squared, is half a Newton, 0.5 newtons. With 1/10 of a Newton friction force on the cart. Then in blue at the top of the page, net force is mass times acceleration. The only force that causes this thing to move is the weight of the 50-gram mass. The weight of the 2 kilogram mass doesn't matter because it's just pushing down into the table. The cart is just applying a normal force to the table with its weight. So the net force is a half a Newton minus 1/10 of a Newton because that's the friction force. And that's equal to the total mass of both of the two objects together, the total inertia of the two objects together, 2.05 kilograms multiplied by the unknown acceleration. Subtract to get 0.4 newtons, divide by 2.050 kilograms, and you get about 0.195 meters per second each second. Then, in green and red, find the tension two different ways. You have to, because tension is an internal force, you have to use free body diagrams, or one free body diagram, either the green one or the red one, either the hanging mass or the cart, to find the tension. Remember that the acceleration direction is the positive direction for the forces also, because that is a vector equation. So the net force is mass times acceleration. In green, you would use 0.5 newtons, which is the weight, which is the forward force, minus the tension, which is smaller than the weight, which is the force applied backward to that object, is equal to the mass of just that object, because with this free body diagram we isolate that object, multiplied by the acceleration that we found in blue in the first part. And tension turns out to be 0.490 newtons. Now the tension in that string should be the same tension all the way through, because the pulley has minimal mass and there isn't any friction there. So the tension applied to the 50-gram hanging mass should be equal to the tension applied to the 2 kilogram cart. So on the right hand side in red, there's a 0.1 Newton friction force, as mentioned before, acting backward on the cart, a tension force acting forward on the cart, and so filling in the net force is mass times acceleration, with the acceleration direction being positive. Tension minus 0.1 newtons is equal to 2 kilograms times the acceleration we found in blue in the first part. And the tension turns out to be exactly the same thing. Obviously you don't have to do both the green and the red. Pick one and solve one of those two, and you've found the tension and the acceleration.